The kitchen functions as an active workspace, requiring a fluid, constant human choreography. Unloading a dishwasher requires a steady back-and-forth rhythm. If a traditional cabinet door is left open during this process, that rhythm immediately breaks. You create a physical traffic block and position a solid piece of wood at the perfect height for a head strike. Look at the narrow cabinet doors in this vintage kitchen layout. They fracture the room into a chaotic vertical grid, dictated by ancient hardware. The traditional swinging cabinet door acts as a physical obstacle. It represents a design failure that works against the natural requirements of human movement. A single 6-foot wide cabinet is cheaper to build than 3 narrow ones, and it holds significantly more. The geometry of the swing prevents us from using that efficiency. In this top-down blueprint, watch what happens when a 6-foot door opens on a standard hinge. It carves out a massive danger zone that blocks the entire room. A simple, primitive piece of hardware, the swinging hinge, ruins the spatial potential of the modern kitchen. But if we fundamentally change that trajectory, if the cabinet face moves up and away for the user rather than swinging outward, the entire room opens up. Keeping a solid wood door suspended without it crashing down requires intense mechanical force. These weathered metal tension springs show the raw power traditionally needed. Modern lift systems use a technology called the variable stop to manage these forces. In this vector breakdown, watch how the downward pull of gravity and the upward spring tension perfectly cancel each other out to neutralize gravity. This transforms a heavy wooden barricade into a completely weightless, hovering object that patiently waits for you in midair. Kitchens have strict spatial limits. Low ceilings are vertical obstacles. Tight corners block swinging doors. They require unique mechanical hacks. This bifold model clears low ceilings by folding the door in half midair. Shifting to parallel levitation, a solid door slides straight up the vertical axis. Finally, the up and over mechanism traces an arcing trajectory, resting cleanly on the cabinet roof. These trajectories are engineered to fully rescue human movement from the frustrating obstacles of traditional architectural constraints. Ensuring these systems survive a lifetime requires extreme kinetic stress testing. This testing arm violently opens and closes the cabinet door at high speed, proving the tension systems can clear a 200,000 cycle guarantee. These systems also integrate electrical touch-to-open technology. A light tap of an elbow opens the door, and a simple press of a button glides it shut. Yet all of these industrial-grade tension springs and electric motors are designed to be entirely concealed behind minimalist silk white or dark gray cover caps. Industrial robotic power sits behind quiet, domestic woodwork, performing its task without revealing its presence. This enables a new flow state in the kitchen. Unloading the dishwasher becomes frictionless because 6-foot cabinets can be left wide open, hovering safely above your head. Without the need for narrow swinging doors, we can eliminate the vertical grid. In this elevation view, watch the chaotic vertical lines fade away. They are replaced by clean, uninterrupted horizontal lines spanning the top and bottom drawers. Architectural harmony is achieved when the hardware removes itself from your physical and visual path. Changing the physical trajectory of a door rearranges the kitchen into a safer, frictionless environment.